Please join me in welcoming Michael Marshall with Stantec Consulting Services. And he'll help us with some data-driven asset management.
Hello, I'm Michael Marshall. I'm with Stantec Consulting. I've been with them for about 10 years now, mostly in inspection and asset management. So I'm a drone pilot, Sprat 1, inspect the bridges, and also help with asset management programs, which is what we're going to be talking about here today. So first off, we're going to talk about why asset management, some examples of how local agencies have developed their asset management programs and where they've come over time. And then we have 3 examples of different local agencies that have come to us and we've helped them with an asset management program. The first being, I would like to call a basic example, bridge prioritization, and then the last being a little more complex of future funding for an asset management program. So first, why asset management? Why are we here today? Most local agencies, they receive their inspection reports back from the field and they flip right to the maintenance section and the photos. And they say, here's my needs, and start to go to work. So first off, where's the subjectivity versus the data? So how are you actually making these decisions to go do this bridge first versus the next? After that, it's where is our budget? Do I have a limited budget versus what our needs are? So many of the agencies come back and say, I have X amount of dollars that I need to adjust for, or at least perform in the first year, but I don't have that budget, at least in the first 5 years. So how do I make these decisions of, let's conduct this maintenance first, this maintenance section at second, and then defer the rest? Again, it's subjective versus non-subjective decision making. How are we making these decisions, and how are we proving to our taxpayers that we're making the best decisions in terms of cost benefit? And the goal, of course, is to become more proactive rather than reactive. So more preservation than we are reacting to our maintenance reports. So here's an example of how an agency has actually performed asset management in the past. Inventory of about 200 bridges. They would receive inspection reports back from the field, and they would flip right to the maintenance and determine, here's where our projects are at. Here's where our maintenance needs are. And they would list those projects out on just a whiteboard. They would then transition that over to Post-it notes, and Post-it notes from the left side of the room in a conference room all the way over to the right. And as a team, they would determine where is our needs. The ones on the left would be the high priority, the ones on the right would be the low priority, and it's moving the Post-it notes across the room. How are they making those decisions? They're making them based off of subjectivity, where maybe the phone calls are coming in from the traveling public, or what they know about their inventory. The other fun fact about this one, they had a list of 200 bridges, and they were having a plan to replace 1 bridge per year. So already their asset management program was setting themselves up to, in 200 years, have the entire inventory replaced on a 50-year life. There's a million ways to solve this puzzle. If you're an agency that maybe has 5 structures in the inventory, that might work for you. Putting the Post-it notes might only cover half of the wall. But if you have maybe a little more complexity to your inventory, size, everything, inventory complexity, size, and essentially, where are all your assets? Are they spread across the region? Are they confined into one area? It all comes into the puzzle of what works well for you. And there is no one-size-fits-all approach. Every agency has their own needs. Every agency has their own internal resources, and it depends on what works for them in order to make those decisions. So the end goal is to become more non-subjective. How do we prove to our taxpayer, how do we prove to our traveling public why we're making decisions? Why are we establishing maintenance for this bridge and then deferring the next? Providing the backup in terms of data. And last but not least, but more important, is the safety of the traveling public, is not ignoring those safety maintenance items and getting those done first. The project examples. So these were local agencies that we assisted in creating an asset management program. So again, the first is going to be a bridge prioritization, a little more basic example. The second being a bridge and maintenance prioritization, a little more in depth. And the last being a structured deterioration modeling and funding. So the first project, the scope was approximately 100 bridges. They previously used the inspection reports to determine where their maintenance needs were. So they receive, again, the inspection reports from the field, flip right to the maintenance, and that maintenance list would then go to their internal team. That internal maintenance team would then go conduct what they could and report back to the asset management program, this is what we could do, here's what we still have left, and the rest would then be contracted. So the issue they had right away was, how am I going to make these decisions of getting this done first versus this second? And they also needed a way to sort through their maintenance, a very simple list rather than going through their reports. Then deferring maintenance, which we'll get into here in just a minute. So the first step we took was getting all of their maintenance onto one single database. With that came a timing criticality and a maintenance code. So the first thing we worked with the agency was, which maintenance codes are you capable of doing internally? What do you have the resources to do? Because that was a completely different budget. And then we were able to divide the line between this is that pool of funds of internal versus that's this pool of fund versus external. Next, we added additional variables such as status and auxiliary hurdles. This might be traffic control, the need for a bucket truck, environmental hazards, anything that you might think of that would magnify the problem of fixing or repairing that defect. One thing was very clear once we had this list was there was a lot of maintenance items that were timing supposed to be done within 1 year, and it nearly tripled the amount of funds they had for maintenance. So they needed a way of deferring. So next, we wanted to take another level in, and that's a bridge prioritization score. So why should we conduct maintenance on this bridge versus another? And there was a big formula that came into this, but essentially the bulk of it is the ADT, detour length, structurally deficient bridge, or fracture criticality. So for this agency, this can vary very much between the local agencies, but this one in particular, they were more focused on structurally deficient and fracture criticality bridges. So you can see already out of 100 score, the highest score a bridge can get without being structurally deficient, without being fracture critical, was 40 out of 100. So it magnified those bridges for their priorities, and we were able to then set their filtering for their maintenance list a little more accurately. Next, they had a list of rehabilitations that were ongoing and a list of rehabilitations that were being done within the first couple of years. So it wasn't necessarily that we were going to say, well, defer those maintenance until the bridge is replaced. It was more, first, let's look and see what that maintenance action is and when is it set to be rehabilitated or removed. Those are, I would like to call the safety and structural items. Things that were deferred, let's think of a delamination and abutment that's not underneath a girder, that doesn't cause a safety issue or a structural issue. Defer that until it's replaced. So this is an example of that manual intervention that we had to make within the program. Not everything could be just data-driven, that you had to go in and say, defer this on, or actually let's do this before it's replaced. The end result was 2 lists, one for the internal maintenance team and one for the external. So the internal maintenance team was a top-to-bottom approach. It was prioritized based on that score we talked about, and the same with the external. Basically, you would go through and say they were able to then create contracts from top to bottom. But one thing that was really interesting about this study was it actually provided some guidance to when we should train the internal team on how to do certain maintenance codes. An example of that might be patching in concrete. If that internal maintenance team does not know how to patch in concrete, they can go to the external list and say, we're going to save X amount of dollars on the contractual side if we train and get the right equipment to do it internally. Same with a bucket truck. You might see that all these maintenance items are on the external side because the agency didn't have a bucket truck. If we acquire one, this is how much money we're going to save. Where's the cost benefit for that? Next, it's a very similar example of bridge maintenance and prioritization with a little bit of extra calculation and risk. And the reason why this one kind of differs a little bit is we were doing the inspections as well as providing the asset management program. So we had the luxury of adding in our variables and establishing more organizational methods with this one. The agency had 3 main goals: safe condition, acceptable level of service, and minimize their capital expenditures as much as possible. In the end, they wanted a recommended project list back to them on what to do first. So we took this in 4 steps in terms of the asset management program. First, maintenance categorization. It's the variable steps that we'll go over next. Then prioritizing both the elements and the bridge, which I'll go over, and then assessing the output. First, maintenance categorization. We first added extra fields. That seems to be a theme in the first 2 examples here. And making sure that you had all the data you needed to sort, manipulate, and see the data in its whole. If you only have maybe 4 or 5 variables, it's hard to sort on something you don't have. So it was adding those extra variables that we talked about in the first example, setting our categories of maintenance actions to reactive, proactive, a deferred maintenance item, or a routine maintenance item that might be cyclical. And lastly, they had the same sort of funding as the last agency, where they needed to have internal versus external type funding. Next is prioritizing. So this was done a little bit differently, where every element that made up the bridge in terms of the MBIS was established a risk score. So you can see the variables in that table, but in the end, it's probability of service interruption magnified by the consequences of that service interruption was assigned to every element. And that might be, is the element ductile or brittle? Is it redundant or non-redundant? And all sorts of variables went into this. Next is prioritizing the actual bridge itself. And you might ask, we've already prioritized our elements. Why are we prioritizing the bridge? With this agency, the assets were so widespread that they didn't want to have to jump between bridge to bridge. Once they got their final list, they weren't going to go to bridge A, then B, then C, and then back to A again. They wanted to be able to go to a bridge, conduct all the maintenance there, including the proactive ones, and then move along. So this at least gave us a risk in terms of the element and then a risk in terms of the bridge. And the scoring was done very similarly, where it was actually a sum of all the risks of the elements involved in the bridge. And then they were assigned a category of low, medium, high to high, and a medium. And what was interesting here is it wasn't necessarily that every single bridge was a high risk. They were all compared against each other. So you have an even distribution of, even if it was considered high risk in terms of a different local agency, it was a low risk to theirs based on the rest of their inventory. And the last thing that was added was a bridge condition index, which is essentially a health index taking into account all the conditions of the elements and summing them up into an overall condition. The last part of this was assessing the output, addressing the highest structural items first and safety items. So again, this was skipping from bridge A to B to C because you want to make sure you get those safety maintenance items out of the way before you moved on to the next. So first was getting all those safety issues maintained, and then it was moving on to the internal team. They would then go out and conduct their rehabilitation on what they could, and then move on to the external maintenance with the budget that's left. And I don't think we made it to this step, but if there's still budget that's remaining, it was going into the proactive approach and being more proactive rather than reactive. Last example is more structure deterioration and modeling and funding for future forecasting. In this one, the scope was more towards scoring the structure in terms of health, using the elements from the MBIS, developing a deterioration of those elements, and then lastly, developing repair actions that could be made to establish future funding. First is scoring the elements. The simple as taking the condition states from the MBIS, condition states 1 through 4. You can think of condition state 1 as being 100%, condition state 4 being 0%, and establishing an overall health score to that specific element. Next, we took it in terms of weighting each element as its risk to the bridge. So you can think of a superstructure getting a high risk, let's say 10, and a joint down to maybe a 3. And those were adjustable depending on how the agency needed them. When you take those factors times their score, you end up with an overall health of the structure. So you can see in this example, we had relatively high or good condition for element 2 and poor condition for element 4. So the blue line kind of represents how the element score varied between those 4 elements. They were then taken times a weighted factor, and you get your gray line, which is your overall health of the structure. Not only this, but we also took this in terms of the overall system. Each bridge then was given a weight and ability to show not only here is your element condition score, your bridge condition score, but here is your system score. So again, similar graph that I'm not showing up there. But overall, we were able to show condition from the bottom all the way to the top. Okay, so now we have the condition of our structure. We then took it with Markovian deterioration modeling and did a transition probability matrix. So this essentially established, okay, well, I have in year 0, our structure is 100% in condition state 1, at least we hope so. And then the next year, 4% of that quantity would be going into condition state 2. After that, that 4% has a probability of going 6% into condition state 3, and so on and so forth. So this at least gave us a curve of what our condition would do over time. So you can go in and see, you may not follow this curve exactly, but you can actually see where you are in terms of percentages on that scale. And now we know where our condition is and where we're going. So the last step in this project was to develop the action and repair items that are associated with bringing our curve back up to normal or as close to normal as we could. So we had to develop first, what are the improvements that can be made to each element? How do those factor in terms of benefit? And what are the costs of each of those actions? So going back to our deterioration graph, we basically split this into minor, major, and replace. So if we were to go out and, let's say, clean off a joint or do a simple patch, that might be a minor maintenance done at year 15, small cost with a small accelerated condition. And from there, our deterioration curve would continue. Major maintenance, similar thing, but higher cost and a little bit more of a benefit towards your condition. And again, your deterioration model doesn't actually reset all the way to 100, but just gets us a little bit of a benefit. And lastly, you have a replacement. So where do we have that large cost and a complete reset of our deterioration model? So if you take these onto account, we can establish where is our goals? Where do we want to end up with this structure or with this system? So you can see our target line is 66%. So maybe it's doing multiple minor maintenances every 5 years, or a major maintenance at year 20 and then a minor maintenance at 25. How does that look? And from this, we can then forecast, if we do minor maintenance every 5 years, what does that cost? If we do major maintenance once every 10 years, what does that cost? But one thing was definitely evident, that bridges and our elements on the bridge are not just developed in terms of condition, but also a life. So you can think of this in terms of a system element or a waterproof membrane or a joint even, where even though the condition is still in relatively good shape, there is still a service life of it. So in this case, you can think of a 50-year service life, just a straight line deterioration model. I would like to get this replaced prior to it completely exceeding its service life. So here you can see we're actually scheduling to replace it prior to 25%, trying to get that project on the books before we completely lose it. So the end result was allowing the agency to set condition state targets and goals and push forward what does their forecasting look like in terms of funding? How much money are they going to need? Going back to our original example, replacing one bridge every year over 200 bridges wasn't going to work out. So how are we going to forecast that money over time? And also, by showing that deterioration model, what is the best decision we can make in terms of a cost benefit from minor, major replace towards that structure. The last thing I'd like to leave you with is additional items for asset management. It's not just start and stop with the MBIS, but it's important to do testing in terms of chloride sampling, GPR, infrared. Different types of testing get you more closer to where you are on that deterioration line. It also gives you more information to work with in your asset management program. You might also do additional site visits with drone 3D modeling, doing extra items with your high-risk structures to determine where you are at and where you need to go with those structures. And again, it's further detail data to lead towards a better program. So the takeaways, the biggest one is one size does not fit all. Each example was very different, and each example came up with the results that the client needed. But in the end, you want them to be non-subjective as much as possible and get it data-driven. So that way, when someone comes back to you and says, why did you make the decision? Why did this get deferred? It's at least data-driven rather than the first phone call that came in from the roadway user. Last is intervention and customization is very important. With every example you saw today, it wasn't just a one-time, let's establish a weight. It was establish your weights and then go back and do an iterative approach. Does the output make sense? And if you create those customized weights and the ability to fine-tune, you can then come back with a better result or easier to extract new results. So I'll leave you with one last quote. It's using the data you have to help drive decisions, using those data points that you have from your inspection records in terms of local agencies to make your better decisions rather than just what is the first phone call that comes in. So thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.